Today we are going to discuss about the differentiation, our third topic of basic mathematics of physics. In this topic, we will discuss about the difference between two terms. We'll discuss about the difference between two terms. First, read the topic name is differentiation. What the meaning of differentiation? Differentiation means differentiate the terms or find the difference between two values. Differentiate the terms or find the difference between two values with respect to another value. I repeat again, find the differentiation of the term or find the difference between two terms with respect to another. Okay, so the first one is finite difference. What is the finite difference? Suppose we have two values. The first value is x1 and the second value is x2. x1 has the value 8 and x2 has the value 6. The difference between them is defined by delta x. The difference between x2 minus x1 is defined by delta x, that is 2. So what is the delta? Delta represents the finite difference. Delta represents the finite difference. So if we read the definition of finite difference, then we can say the actual and finite difference between two values which has large difference between them. Actual and finite difference between two values which has large difference between them. So there is no fractional change in the two values. It is the finite difference. Finite difference we can measure easily. Finite difference we can measure easily. There is no any such requirement to measure the finite difference of instruments or any other equipments. So we doesn't require any other equipments to measure the finite difference. Finite difference is basically the simple difference of two values. Okay, it is clear. Now we move forward. Now we discuss about infinite small difference. Infinite small difference. The infinite small difference is defined by or represented by small d. Infinite small difference d is defined or represented by small d. So read the definition. Very small difference of approximate values to 0 between two values. Very small difference approximate to 0 between two values. So read the definition. Very small difference approximate to 0 between two values, but it should not equal to exactly 0. So what is the meaning of this line? This line represents that the difference between two values is approximately to 0, but it should not exactly 0. Okay, it should not exactly 0, but it is approximately to 0. So this value will be very small, like 0.000001 etc. Okay, now let's see. This is y. Y is the function of x. We have discussed this problem in the topic of function. Y is equals to fx. It is called as function of x, and the differentiation is defined by or represented by f dash x or y dot or dy by dx or dy by dx of f of x. Clear? We can represent the differentiation in different terms. First one is f dash x, the second one is y dot, the third one is dy by dx, and the fourth is dy by dx of d upon dx of f of x. So these are four formats to define differentiation. But what is the differentiation? let's we understand it. Let's see what is the differentiation. You can see here the diagram. Here is the scale. This is the scale, and the length of this scale is y meter. The length of this scale is y meter. Okay, and there is a second scale whose length is x centimeter. Clear? The first one is first scale, that is the length of first scale is y meter, and the second scale's length is x centimeter. Now we have two scales here. First, we have to differentiate the first scale that contains the length y meter. The length of one division is dy. So the total length y is equals to 100 into dy. There are 100 divisions. Actually, we can't draw the 100 divisions here. So you can assume that the divisions are 100 in the number. So the total distance is y meter. Y is equals to 100 into dy. Clear? Now let's take another scale. We have the another scale which is the centimeter scale. The length of this scale is x centimeter. Clear? The length of this scale is x centimeter, and it is again divided into 10 divisions. It is again divided into 10 small divisions. So there are two values same as the previous scale. The first value is x1 and the second value is x2. The difference is dx is equals to x2 minus x1. So there is a small difference between x2 and x1. So we can say if divisions are 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divisions are 10, then the total length x is defined as 10 into dx. The length of one division is dx. And the total number of divisions is 10. So the total length is defined as x is equals to 10 into dx. It is clear? Now we move forward. We want to make a box. Of length dy with many number of boxes of dx length. That means we want to make a box which have dy length. We want to make a box which have dy length, and each box has the length dx. Each box has the length dx. How many dx length boxes are required to make the box of length dy? Okay, we already find it that y is equals to 100 into dy and x is equals to 10 into x. Clear? So we can write dy by dx, and the value of dy is 4y upon 100, and divide this value because there is a division, or we can say there is a ratio of dy on dx. So the value of dy is y upon 100. Divide it by x upon 10. Divide it by x upon 10. So we can say y upon 100 into 10 upon x is equals to 1 by 10 into y upon x. Clear? So dy by dx is equals to 1 upon 10 y upon x. Suppose if y is equals to 1 meter and it is equal to 100 centimeter. 1 meter is equals to 100 centimeter and x is equals to 1 centimeter. Okay, so we can say dy upon dx is equals to 1 upon 10, 100 centimeter upon 1 centimeter. Centimeter cancel centimeter, 10 cancel 1 0, and we get number 10. So dy upon dx is equals to 10. We can write here dy equals to 10 dx. So how many number of boxes of length dx is required to make the one box of dy length? There are 10 boxes are required to make the large box of length dy. Clear? It is clear. Now we talk about the double differentiation. What is double differentiation? You understood what is differentiation. Now we will do double differentiation. So in differentiation, we represent the differentiation of x as differentiation of function x after as x y dot dy by dx and dy by dx of fx. Clear? For double differentiation we mark 2. For double differentiation we mark 2 times. How? We represent the double differentiation as f double dash x y double dot d dash y upon dx dash d dash upon dx dash of fx, or we can say d square y upon dx square. Is it clear? This is the representation of double differentiation. We have to find differentiation first and then again we have to differentiate this result of differentiation. Is it clear? Now we move forward. Now we will talk about the average rate of change. We will talk about the average rate of change. So let's discuss. It is defined as delta y upon delta x. What is the delta y? You have to see the figure. We have to find out the value of delta y. There is a curve you can see in the figure. This is the curve. This is the curve, and the point is P and the point is Q. Okay. In this figure, the first value is y and the second value is y plus delta y. Okay. The second value is y plus delta y. The difference is delta y. The difference is delta y between both the values in y direction. Okay. Now what is the delta y? The delta y is the difference between function of x plus delta x minus fx. The function of x plus delta x minus function of fx. As we before seen that y is equals to fx. So we calculate these terms. Here the input is x and here the input is x plus delta x. We get the difference between them is called delta x, that is represented as here delta y. Sorry, we find out the value of delta y and we represented here delta y in the figure. Now tan theta. What is the tan theta? Tan theta, slope of line PQ. What is the tan theta? Slope of line PQ. This line is called tan theta. This line is called the slope of curve PQ. This line is called slope of curve PQ. Then we can find out here tan theta. Tan theta, we have discussed about tan theta in trigonometric relations. So tan theta is equals to delta y upon delta x. Delta y is here and delta x is here. So tan theta is equals to delta y upon delta x. So we can write here delta y is equals to fx plus delta x minus fx upon delta x. Is it clear to you? Now we move forward. For a small change, we have to put delta x equals to delta x tends to 0. For a small change, we have to put delta x tends to 0. Now, what we are doing? We are finding the value of differentiation of y with respect to x. We are finding the differentiation of y with respect to x. So what is the differentiation of y with respect to x? When we put the value of delta x tends to 0. That means as we decrease the value of delta x, we can write here f dash x is equals to dy by dx. Now we put the limit. We put the limit for delta y upon delta x. The limit is given here. Limit is delta x tends to 0. It is not equals to 0, but it tends to 0. When the value of x is decreasing and the value of x is reached at the point 0, but it is not exactly 0, then we can say that the difference in y is very small. The difference in y is very small. How can it will be? We will discuss it sometimes later in this section. Provide the limit for average rate of differentiation delta x tends to 0 and we get dy by dx. That is very small value. So how it is going we can discuss. So we discussed this in this segment, geometrical analysis of differentiation. According to geometrical analysis of differentiation, we can see here there is a secant and there is a secant. What is the secant? A straight line which intersect at 2 points on the curve. So where is the curve? Curve is here. This is the curve PQ. And where is the line which intersect at 2 points? There is a straight line which intersect at point P and at point Q. This is called secant. Now, this is the secant and we have to find out differentiation, that means dy by dx. So how can we it find? Let's move forward. So we can see here, to find out the differentiation of y with respect to x, we have to find out tan theta or tangent or slope. So what is the tangent? What is the tan theta? What is the slope? To find out the tangent, we have to decrease the value of delta x up to 0. We have to decrease the value of delta x up to 0. Let's see. Suppose it is the starting position where the straight line draw, and in this condition the length of delta y is here. Okay, the length of delta y is up to here and the length of delta x is up to here. Clear? Now decrease the value of delta x because we put the limit delta x tends to 0. So in graph we have to decrease the value of delta x. Decrease the value of delta x from this point into this direction. So as the delta x decreases, the slope or the line is moving like as. As you can see, as the value of delta x decrease, the point shift from here to here. Now again we decrease the length of delta x, then the slope move from this point to this point. Clear? As we decrease the value of delta x, the value of delta y is also decreased. I am saying that as we decrease the value of delta x, the value of delta y is also decreased. So as the value of x is going to dx, then the value of delta y is being very small and it is become dy from delta y. So value of delta y has become dy because of the value of delta x is becomes dx. We can see here as we can see here in the graph, as we decrease the value of delta x, the value of delta y is also decreasing, and at some time the straight line touches the curve at this point. The straight line touches the curve at this point and then it is called tangent. Then it is called tangent. How? If you can't see here properly, then you can see here in this graph there is a line which touches the curve here, and this line is called slope and this line is called tangent, or it is represented by tan theta, and it is also the differentiation of y with respect to x. So overall analysis, you can see here how to find differentiation and what is the differentiation. So we can summarize here that as we decrease the value of delta x towards 0, the value of delta y also decreased. As the value of delta y decrease, the slope moving downward direction. As the slope moving downward direction, it touches the curve at some point, we can mention here, and when the slope touches the curve like as, then it is called tangent, and the tangent also called differentiation of y with respect to x. So it is clear to you. If you can't understand any term, any values, any concept, then you can ask me in the comment section, okay, or you can mail me. I will give you answer for everything. There are some basic formulas for differentiation. How we can find the differentiation? To find the differentiation, there are different formulas. The first one is dy by dx, and we put the value of constant. If we differentiate the constant value, then it is called 0. The constant value can't be divided or can't be differentiated. So the value of differentiation of constant is 0. The second one is y is equals to d upon dx. In bracket, we put the value x power n. So we are finding the differentiation of x power n with respect to x. The formula is n x power n minus 1. So in this formula, we put the n here and put the value n minus 1 here. Then we have to minus from the previous value which is given in the formula. Okay, now move further. If fx is equals to x power 4, as an example, if fx is equals to x power 4, then y is equals to f dash x, that means differentiation of x, then it is 4x power 3. Before the value of n is 4, here the value of n is 4, so the differentiation value is 4x power 3. It is clear to you? Let's see the next example. The next example is if fx is equals to x power minus 7, then y is equals to f dash x. That means the differentiation of fx is equals to minus 7 x power minus 8. Here comes 8, not minus 6. So this is minus 7 x power minus 8. Okay. Now let's move to formula third. Formula third is y is equals to d upon dx bracket c fx. C is the constant here, so v comes out the constant c d upon dx fx. So this is the third formula. Let's take example. If c is 4 and fx is equals to x power minus 5, then y is equals to, that means y is the differentiation of fx. Y is equals to c f dash x is equals to 4 minus 5 x power, here comes minus 6, not minus 4. 4 1 minus 5 x power minus 6 is equals to minus 20 x power minus 6. You will correct here, don't put it here minus 4, put here minus 6. Now let's see the example number 4. Y is equals to d upon dx u plus y. There are two terms u and the second term is y, so we can write here du by dx plus dv by dx, du by dx plus dv by dx. Okay, the fifth is y equals to d upon dx u minus y. In the previous one there is u plus v, and in this formula there is u minus v, so we can write du by dx minus dv by dx. Clear? In the sixth formula we can see y is equals to d upon dx uv, so we have to write it u dv by dx plus v dv by dx. In first we will find the differentiation of v with respect to x, and u is the constant term, and in the second plus v is the constant now, and du by dx is the differentiation of u. You have to remember, or you have to learn all the formulas as it is. Now we move forward. Seventh formula, y is equals to d upon dx u upon y. In fourth formula we have seen sum u plus v. In fifth formula we have seen the difference or u minus v. In sixth formula we have seen the multiplication, that means uv, and the seventh formula we will see the division, that means u upon v. So how can the differentiation is going place? So the formula is v du by dx minus u dv by dx, okay, upon v square. This is the formula. You have to learn this formula. Now we can see here the example. For example, if fx is equals to u upon v is equals to x square plus 2x upon x minus 5. The value of u is x square plus 2x and the value of v is x power minus 5. So the differentiation is x power minus 5, that means v d upon dx. Here the u take place and the value of u is x square plus 2x minus x square plus 2x d upon dx, and the value is x power minus 5, that is v. Okay, upon v square, that means x power minus 5 square. Is it clear to you? Now we will see derivatives of trigonometric functions. We already discussed about the trigonometric function in the previous video you have seen. So what are the derivatives of trigonometric functions? The differentiation of sine x is equals to cos x, differentiation of cos x equals to minus sine x, differentiation of tan x equals to sec square x, or we can say 1 upon cos x square x, differentiation of cot x is equals to minus cos x square x equals to minus 1 upon sin square x. Same as you have to learn all the formulas. Now again we can see the next formula is formula number 9, that is y equals to d upon dx log ex equals to 1 upon x. This is the logarithmic function. and we can say it log function. If the value is in log, then the differentiation of log ex is equals to 1 upon x. Y equals to d upon dx. The function is ex and the differentiation of ex is also ex. In 11th formula, y equals to d upon dx sine x degree. So we can write here d upon dx sine pi x upon 180, because in 1 degree is equals to pi upon 180 radian. In 1 degree there is pi upon 180 radian. So we can say x degree is equals to pi upon 180 x. Is it clear? Now in this term, pi upon 180 is constant term and x is variable. So x upon 180 is here and the differentiation of sine x is cos x.
Okay, let's we talk about the maxima and minima. What are the maxima and minima? Suppose we have a function and we want to find out the maximum value in this function and we want to find out the minimum value in this function. Then the condition of maxima and minima will give the value of maxima, maximum and minimum. So let's start. There is a graph you can see here. In this graph, this is the x-axis and this is the y-axis, and the maximum value at x1 is here and the minimum value at x2 is here. How can we find the value of x1 and x2? Actually, x1 is the point where we will get the maximum value of y and x2 is the point where we will get the minimum value of y. To find these value, we have to fulfill two conditions. First, we see for maxima. In maxima condition, first we have to find out dy upon dx. First we have to find out dy upon dx. The dy upon dx is the differentiation of y with respect to x. So the value of dy upon dx should be 0 in the first condition. We put the value of dy by dx equals to 0 in the first condition. In the second condition, we have to differentiate again it. We have to again differentiate it. D square y upon dx square is less than 0. That means the double differentiation value should be less than 0. So analyze the graph to find out maxima and minima. Okay. First we will talk about the maxima. Let's see here. This is the condition for dy by dx is equals to 0, because the slope is the straight line. When the slope is the straight line, the value of tan theta is 0 and the value of tan theta is 0, then dy by dx is equals to 0. This is the first condition. Now I'm asking you that in which condition we will get the maxima. In which condition we will get the maxima. Okay. There is the point 0. Okay. When we move into the right direction from 0, we will get the maxima. When we move into the right direction from 0, we will get the maxima, and we will move into the left direction, we will get the minimum. It is clear to you? Now, if we get the maxima in the right direction, then what is the curve in the right direction? The curve is here. The curve is here. So make a tangent to this curve. So we draw the tangent to this curve like here, and this tangent and the x-axis make the angle theta. This is the angle theta, and this angle theta will go into second quadrant. This angle theta will go into second quadrant. So in second quadrant the tan theta is negative. In second quadrant tan theta is negative. As we see in the second condition, d square y upon dx square is less than 0. So as we move towards right, the value of tan theta is also 0. Sorry, it's also negative. So it is the less than to 0. So second condition is satisfied. Okay. Now we will talk about the minima. Let's check here. First condition is dy by dx equals to 0. So here is the dy by dx equals to 0. To find out the minima, we have to move in the left direction to the 0. So where is 0? 0 is here. And we have to move in the left direction, that means in this direction. And when we move into the left direction to the 0, then we will get minima. Now what is the curve in the left direction? This is the curve in the left direction. So we make a tangent to this curve. Let's make a tangent. This is the tangent, and it make the angle theta here. Okay, it make the angle theta here. But in this condition, as we can see, this is in the second quadrant. This is in the second quadrant. But as we see, we measure the angle from here in clockwise direction. We measure the angle from here in clockwise direction. So the theta is negative. The theta is negative. It is not positive. When the theta is positive when we measure it from anti-clockwise direction. But we measure the angle theta in clockwise direction, so we can write here the theta in the form of negative theta, minus theta. Okay, but it is in the second quadrant, so we have to write minus tan bracket minus theta. We have to write minus tan minus theta. So the value is tan theta. So we can see that in the left direction of 0, the value of d square y upon dx square is positive. Then the second condition is satisfied. If d square y upon dx square is greater than 0, then the function will give the condition of minima. So it is clear to you then when the function is maximum and when is the minimum. Okay, let's move forward.
Examine each function for maxima and minima. So first we see about a. In the first example a, we will see y equals to x cube minus 3x square plus 2. We have to find out the conditions for maxima and minima. In first example, we have to find out dy by dx. So let's find. The first one is y equals to x cube minus 3x square plus 2, and the dy by dx is equals to 3x square minus 6x. According to the condition, we have to put dy by dx equals to 0. So 3x square minus 6x equals to 0. So we can say 3x bracket x minus 2 equals to 0. So x equals to 2. When we put dy by dx equals to 0, then we get x equals to 2. That means when the value of x is equals to 2, then the slope will become 0. Now find d square y upon dx square. D square y upon dx square. So what was the value of dy upon dx? The value of dy upon dx is equals to 3x square minus 6x. So the value of d square y upon dx square equals to 6x minus 6. Now put the value x equals to 2 in this equation. So we can say that d square y upon dx square equals to 12 minus 6 is equals to 6, and 6 is greater than 0. 6 is greater than 0. That means it satisfies for the condition of minima. It satisfies the condition for the minima. So function is minima. Okay. Now let's we see the another example. The second example is here. The second example is here. Y equals to 2x cube plus 3x square minus 12x minus 4. So find the value of dy by dx. The value of dy by dx is 6x square plus 6x minus 12 equals to 0. So x square plus x minus 2 equals to 0. So x equals to minus 2 and minus 2 and plus 1. That means there are two conditions where the slope becomes 0. When the value of x is minus 2 and the value of x is 1. There are two conditions where the value of dy by dx or the slope is 0. Now we will find d square y upon dx square. Is it 12x plus 6? Put the value x equals to minus 2 and find d square y upon dx square. Now we get minus 18, and minus 18 is less than 0. So this is the condition for maxima. This is the condition for maxima. So we can say at the value of minus 2, at the value of minus 2 of x, then the condition of maxima, and for 1, for the value of x equals to 1, you will find then the function becomes maxima or minima. This is the question for you. Okay, now solve this question for x equals to 1 and tell me in the comment that it is maxima or minima. It is clear? So students, this was the differentiation, and we have finished the differentiation. You have seen every concept of differentiation or formulas. You can find the formulas or table for formulas of differentiation on the internet on your maths book. If you didn't get any concept or you didn't understand any concept, then you can ask me in the comment section, and please see the previous lecture. If you're finding the problem in the functions, then you have to see the previous lecture, which is based on function and trigonometry. Is it clear? So students, bye bye. Keep healthy, keep motivated, and please like, subscribe and share my channel to get more videos. When you press the bell icon near to subscribe button, then you will get the every notification of my videos. So please like, subscribe, share and press the bell icon. Okay students, we will meet earlier. Thank you. Bye bye.